9. Ignition sequence start. 6.
Hi, everybody. Welcome to Virtual Night Sky. This is absolutely, we started a little bit differently for those of you that have been following us. What you were just watching is a video that was made by a group of students, and they're part of a program called Psyche Inspired. You're going to learn a lot more about Psyche Inspired and why it exists and what it's all about and the mission it's attached to during the program tonight. But first, let me make some introductions. So first of all, my name is Rick Alling, and I am the manager of outreach programs, usually at the School of Earth and Space Exploration on the ASU campus. With me tonight is some of our regular players. Meg Hufford is my colleague, and she and I are the ones that usually greet the guests, people that come to visit our facilities. During COVID, we've decided to do things a little bit differently, and so every other Wednesday, we're doing this particular program. And for those of you that have been following us all along, welcome back. For those of you that are new tonight, really glad to see you and glad to have you join us. Kim Baptista is on board here. She is the webmaster, and I kind of call her the producer. She is the one that kind of keeps track of the communications. You've heard from her if you registered for the program, and you'll hear from her afterwards. She's going to kind of tap you for a little survey and a thank you for coming. Expect that in a day or two. Two students are with us tonight, Alicia Hyatt and Alex Blanche, and they are fielding questions in the background and helping to keep us organized, and they'll be doing some poll questions as we go along. We have a very special guest tonight, and I'm going to take a moment to introduce you to a mission, and then I will also introduce Dr. Dave Williams, who is at the School of Earth and Space Exploration, and he is also the director of the Ron Greeley Center for Planetary Studies. You're going to hear all about that and the mission we call Psyche. And then in the second half of the program, I just want to show you some night sky things. There's some really exciting things to look at, and I'm going to show you the movement of the moon over the next week or so. We're going to talk a little bit about conjunctions and occultations and what the difference is and what to watch for and some things in the night sky. So we got really a great program. And so before we go any farther, I'm going to share screen. I'm going to take you on a little journey. There happens to be an asteroid in the sky called 16 Psyche. It's an asteroid that has been known for a long, long time, and then more recently known to science to have some very special properties. It's very metal rich, and we don't exactly know why. So let me just sort of like get out here, just reintroduce you to your solar system. There's your Earth, there's your sun, And in between the red orbit, which is Mars, and the yellow orbit, I can kind of point at it, I guess, over here is Jupiter. There is a whole bunch of objects we call asteroids. I have them blown up really, really large on the screen here. I think we learned in school that most of the asteroids organize themselves in what we call the asteroid belt in between Mars and Jupiter. But there's asteroids, it turns out, in a lot of places. Those are yellow lobes in the orbit of Jupiter called Trojan Asteroids. And there's a mission we'll be talking about later that is going to go visit those. Outside of the orbit of Neptune, there's trans-Neptunian asteroids. There's asteroids that are sort of near the Earth. But Psyche is a bit more traditional. Psyche is in the main asteroid belt. Let me just light up an orbit for you so you can see where it is. And then I'm going to actually sort of fly us down to Psyche so you can actually sort of like get a little sense of it and where it is in space. Oops, sorry about that. I am going to actually have to reload for a moment here. This one takes just a little bit to get organized. Let me see if I can find that monster. It is out there kind of on the outer part of the main asteroid belt. And you're going to learn more about the object in a little discussion with Dave Williams. And will, I had this absolutely loaded. Oh, there it is. It's coming into view. I think I can see it now. There it is. So you can see that from this artist's view of the asteroid, it has some special properties. It doesn't look like anything else we've seen. And I can tell you right off the bat, this is an artist conception of what this object might look like. We are participating in a mission that is going to go visit Psyche and tell us a lot more about it. It launches in about a year. And so really the main part of our program tonight is we want to introduce you to this object, introduce you to the mission that's going to go visit this object, and I've learned from Dave Williams, who is an investigator on that mission, what his role is going to be and what we expect to find when we get there. So I'm going to stop share here and reintroduce Dr. Dave Williams. Welcome to the program.
Thank you very much. It's a great pleasure to be here. I'm a research professor in the School of Earth and Space Exploration here at ASU. And, my job on Psyche, I'm what is called a co-investigator. I'm a member of the science team, and I'm also the deputy lead for the multispectral imagers. And those are going to be the cameras that are going to take all the pictures of Psyche, from which we will determine its shape, its surface materials, its composition, etc.
So we should sort of just add, we want to introduce the reason this is so important to ASU and to Arizona and everything else is it's a really big mission. And this is the first time this particular type of object has been visited. But most importantly, the principal investigator, the science lead for the entire mission, is a woman named Lindy Elkins-Tanton. She is also a professor at ASU. And she was awarded this mission because of proposals and a process and to go visit this thing. And so it's amazing. This is what NASA calls a deep space mission, just because of how difficult it is to get there. And she is only the second woman in history to actually lead a mission as such. And Lindy is our very own. So it's been fun for us. We've been very excited about this. Now we're only a year away. And we thought you, my audience, right, the people who are sort of watching the Virtual Night Skies, you better start to know about this because you're going to hear a lot about it over the course of the next year. So Dave, tell us a little bit more about, we're a year away. So what kind of preparation? So you are a lead investigator on a camera system. What kind of preparation are you guys working on now? Are you just waiting, or is there things to happen?
Yeah, right now the mission is in what is called Phase D. That is the final assembly. So the spacecraft itself, the satellite, if you will, was built by Maxar Technologies in Palo Alto, California. And they delivered the spacecraft to the Jet Propulsion Lab earlier this past summer. And then what it's in now, it's in a situation that we call ATLO, and that means Assembly, Testing, and Launch Operations. And that's where, in addition to the spacecraft, they're putting on the computers, the avionics, all of the control systems, the power systems, and the science instruments. And there's basically 3 different science instruments on the spacecraft. There's magnetometers that are contributed from our colleagues in Denmark, and there's a gamma ray and neutron spectrometer that's contributed by our colleagues at the Applied Physics Laboratory at Johns Hopkins University in Maryland. And then there's the multispectral imagers, the cameras, and they're being built by Malin Space Science Systems in San Diego, and ASU is sort of the lead on that. So
on that particular instrument then, yeah.
Yeah, they all of the instruments are in the process of being completed and delivered to the Jet Propulsion Lab in Pasadena, where they'll be integrated onto the spacecraft. And then once that's all done, late this fall, the whole spacecraft with the instruments is going to go through what is called thermal vac. They'll put the whole spacecraft into this giant chamber, pump it down to near vacuum, and then run it through temperature sequences from very, very hot to very, very cold, the extremes that the spacecraft would be expected to endure in space, as a test to make sure that everything is working properly. And
I'm sorry, let me stop for a moment. And I forgot to do this, but audience, we want to kind of answer questions live. This is a little bit of a different format you might be used to. So Dave and I are going to treat this more like a little interview process here. But if you have any questions, and we want you to have questions, we're just going to kind of like stop and answer as we go. So the way to do that is to go down to the bottom of your screen. We don't do chat, but we do question and answer. You just kind of enter on there. Then Alex and Alicia in the background will be kind of watching for that, and they'll stop us and have us do that. And then Alex, I think we'll keep talking, but would you go ahead and run the video of the arrival at JPL? So as Dave was saying, this particular spacecraft was built essentially in the San Jose area, and a really big truck, which you're about to see, actually sort of like delivered it down to JPL in Pasadena just very recently. This is only about a month and a half or 2 months ago. There it is. There's a specialty truck, huh?
So yeah, they're backing the truck into what is called one of the high bays. These are ultra clean rooms, and you see all the people in there are wearing masks and costumes because it's a essentially dust-free environment. And there you see the Psyche spacecraft completed by Maxar, and it's on that articulation frame that allows them to continue to install components and instruments and other systems and test everything out.
That sounds absolutely great. So we've sort of got excited about this. Every time there's a new step, right? Something gets completed, something gets moved, gets transferred to a new location. That's a pretty exciting part of the process. And then back to instruments, I didn't mean to block your train of thought there, but they all have to work together. So this is actually, I mean, we know from the manufacturers and the people that created the instruments that they all work independently, right? But this is the first time that they actually all get together in the same frame, and we sort of make sure that there isn't any crosstalk or any kind of interference between the instruments themselves. And that's an important stipase, right?
Yeah, that is correct. You know, each instrument has its own sort of mini computer system and power system that runs and executes the commands, but there's a central computer on board the spacecraft. So what's going to happen is, you know, it'll be uploaded with commands to execute whatever part of the mission that we're on. And that includes telling the camera to take pictures with specific filters at specific times. At the same time, the magnetometers are probably going to be running almost continuously after launch. And then, you know, the gamma ray and neutron detector, it will also be running, you know, in general, but it's going to be doing much more in the lowest orbit because that's a low resolution instrument. It has to be in orbit D when we're the closest to Psyche to get the maximum useful data. And that's going to tell us a gamma ray and neutron spectrometer tells us about the elemental abundance of the materials on the surface and if there's any hydrogen present that might be present in water ice. So that's going to do that. Each of the 4 orbits of the Psyche mission, A, B, C, and D, is optimized for each of the instruments on board.
Excellent. Okay, I think let's do this. I think let's play a second video. This one was released by NASA today, so you can go find it, and we'll show you where to go find it on your own later. But before today, the general public has not seen this. So this is kind of a new video, and it kind of inspired you, maybe inspire some questions and get you to think about some of the cool parts of this mission. That's pretty dramatic and pretty awesome. So that's another artist's concept of maybe what this thing is going to look like. Remember, I said, and when I played that, I did the fly over the model in the first part of our program. I said, we really don't know what this looks like, but we're imagining what a metal-rich world is. This is 3 years later, and the same artist has produced yet another image. So, Dave, did the artist works with the science team, right? He's not coming up with this by himself. So, what's in that? What are we seeing in that video? It's especially the sort of the colored rocks. I think it's the one with the crystals inside. What are those?
Sure. Well, let me just say a little bit. You know, most of what we know about asteroids is from the light reflected off of them that comes from the sun. And, you know, when we analyze that, you can look at the light and tell what materials make up asteroids. And there's several different classifications of it. And we visited several of them. In the case of asteroid 16 Psyche, it's classified as M, and M in this case means metallic. It seems to be dominated by iron, nickel, metal. And the main theory is that it could be the exposed core of an asteroid parent body that was hit by multiple side-on impacts that would have knocked most of the crust and the mantle off of it. So, you know, just like the Earth, we have a crust, a mantle, and a core. We think that this body would have been like that, but most of the crust and mantle has been knocked off, and that it has a core. Now, when the mission was first approved by NASA in January of 2017, the information that we had existing about 16 Psyche from Earth-based telescopes was that, you know, it could be mostly metal, but subsequent studies suggest there are other components on it. Most certainly there's probably silicate, minerals, like what you would find in Hawaiian basalt, lava flows. There could be other types of materials, covering the surface, maybe not completely covering, maybe only in some areas, and you might have the metallic, basement rock there sticking out around some of this stuff. And that's what was sort of represented in that new artist concept of Psyche. Now, Rick asked about the metal with the sort of yellowish crystals in it. Those are actually grains of olivine, and they're very similar to a type of iron meteorite we call a palisite. A palisite is thought to come from the core mantle boundary of an asteroid parent body. And at that location, you're going to have mantle minerals like olivine surrounded by metal from the core. And if you've ever been to a gem and mineral show and seen pallasites, they're absolutely beautiful specimens of meteorites. And so that particular part of this video is suggesting perhaps that part, at least, of Psyche could be something that could be like a source of palisite meteorites. We won't actually be able to tell that from viewing because we're not going to get that close. But when we point the imagers to look at the reflected light spectra of different parts of the surface, and when we point the gamma ray and neutron detector, that could give us information about whether you have pure metal, whether you have mostly iron or nickel or other sulfides and things that are associated with metals, or whether there could be silicate components on that, where you might have olivine or something like that. So that's sort of the concept of what we're thinking about as far as 16 Psyche right now.
I'm going to ask Alex and Alicia, are there any questions we can take from the audience? We'll take a little break for that.
Yes, we actually have a few questions.
Okay.
One of them that was actually repeated, we have a question from Mike and Stuart. They're kind of a similar question. They're wondering, what about the orbit of the spacecraft? How close will it come? How long will it be with the asteroid? How many orbits?
Well, the way the mission is designed, and if you want to put up
we have some image,
chart,
right? Yeah, let's do
the chart of the way the mission is designed. So when the spacecraft uses its solar electric ion propulsion, it's going to be slowly approach and catch up, and the gravity of 16 Psyche will pull the spacecraft in. And if you want to go to the distance slide, this is just some of the other slides here. The next one, I think. Okay, this slide shows you how the orbital operations are going to be. So when we get there, we're going to be in a high altitude orbit that we call orbit A. And that's where we're going to be imaging. We're going to try and get a better estimate of the shape and gravity of the body. And we'll do our first set of global images at, I think, about 35 meters per pixel. That means you'll be able to resolve things as small as 35 meters on the surface. We'll be there for some period of time. I think it says, 56 days. Then we're going to fire the ion engine and drop down lower into orbit B, where we'll be for 80 days. And that's going to give us a much higher resolution imaging and also allow us to do stereo mapping of the surface to determine a topographic map. Where are the elevation highs and lows? Then we'll drop down, and for about 100 days, we'll be in orbit C. And that's where we'll get high resolution gravity and topography measurements. And then finally, we'll drop down to orbit D for about 100 days. And that's where the gamma ray and neutron spectrometer will make the high resolution compositional measurements. So the whole length of the nominal mission is going to be about 24 months from orbit A to the beginning of orbit A to the end of orbit D.
All right, and then that's probably too small to read the fine print, but what is the approximate distance? Do you know how far away we are at A?
Yeah, it's. I'm sure it says so in one of these slides here. Orbit A is going to be at 700 kilometers altitude. Orbit B at 290 kilometers altitude. Orbit C at about 170 kilometers altitude, and orbit D is at about 85 kilometers altitude.
As it gets closer, is it like more dangerous for the spacecraft? I mean, is this a logical progression? You start really high and then you kind of move in?
It's going to, any type of mass distribution in the inside of the spacecraft or inside the.
Uh-oh, Dave, you lost you just a little bit. Hopefully that's temporary. I think what I'd like to do is just sort of while Dave is frozen and we sort of like we'll work to get him back. Alex, I wonder if you would go back to the slide deck, and I wanted to just show some size relationships. We'll go back there.
Sure thing.
So this is sort of just, so Psyche is represented by that little sort of like target looking thing between Phoenix and Flagstaff. It's about 270 kilometers end to end. It's not exactly round. Asteroids don't necessarily have to be round, and oftentimes they're a little bit potato shaped. And so this one is a little bit like that, but its longest axis is about 270, which makes it, we used to say, about the size of Massachusetts. And it turns out Lindy came from MIT, so that made some sense, but we're trying to relate it to Arizona now. So I'm going to say it would fit between, or nearly fit between Phoenix and Flagstaff on it. So then the next slide shows some just sort of, okay, oh great. And the next slide, I was just going to cover in size while you were gone. So the next slide just shows you a relationship between several asteroids in space. And so there's Psyche. Remember, it's not round. It's a little bit of a potato shape. And the other asteroid represented there is Vesta, which is actually like a minor planet, right? And so Dave, I'll turn it back to you so you could sort of
sure.
talk about
Yeah, Vesta is the most massive asteroid in the main asteroid belt. It was the number 4. It was one of the earliest ones discovered. The most massive is Dwarf Planet Ceres, which, you know, just across its diameter is about the size of the state of Texas. Vesta is about the size of the state of Arizona. And as Rick just pointed out, asteroid 16 Psyche is about the size of Massachusetts if you leave off Cape Cod, or the distance between Phoenix and Flagstaff.
Okay. Gives you a sense of size there. And it's way out there. I mean, this is really closer to Jupiter than it is Mars, right? So I mean, it's the outer edges of the belt.
Psyche, asteroid 16 Psyche orbits at about 2.9 astronomical units, and an astronomical unit is the distance from the Earth to the Sun. So it's almost 3 times that. So it's at the far end of the main asteroid belt between the orbits of Mars and Jupiter.
And then when we go, so we're launching next August, but then Dave, how long does it take to actually get there? I think we have a little map of that too. Maybe Alex.
Yeah, that slide. Yeah, that slide there. It says the cruise is 3.4 years. So if we launch in August of 2022, we'll do a Mars flyby in May of 2023, and that's going to give us a gravitational boost. But also, it's going to give us an opportunity to test all of our science instruments by pointing them down at Mars, and you know, that's a great opportunity to test everything. And then you see Psyche arrival in January of 2026. So from August of 2022 to January of 2026, that's the time that's going to take. And you know, this mission is one that's sort of different in that it uses, as I said, solar electric ion propulsion. It's a type of propulsion that's powered by solar energy that uses a very, very small mass of fuel, but and by doing so, you save a lot of cost because you don't have a massive amount of liquid fuel. But the trade-off is that it takes longer to get where you're going. So that's why we have the 3.4-year cruise phase to go from Earth out to 16 Psyche.
Excellent. And then just real quickly, so as part of the science team, right, you're not just sitting on your hands. You already told me that when we do the Mars flyby, there's a whole bunch of stuff that needs to happen. There's testing that goes along the way. So just because it launches and it takes 3 years to get there doesn't mean everybody's doing nothing, right? We're not waiting. There's some things going on. What goes on in the background? Yeah,
they're going to be monitoring the spacecraft continuously, you know, to monitor it, because it has to fire its ion propulsion at particular times in order to get out there on the expected time frame. There's also an instrument on board. DSOC it's an optical communications. It's going to use an optical laser to attempt communications as it moves out there, and that's what those dots are on that particular map. And at the same time, you know, we're also going to be doing more of this calibration. We're not just going to wait until we get to Mars. We're going to point the cameras at stars and star clusters of a known brightness and color to test the imaging capability of the camera, and if it changes at all during this 3.4-year cruise phase. For me myself, go ahead.
Oh, go ahead.
I was going to say, for me myself, you know, we're going to be getting, and the other science team leads, we're all going to be getting ready for the science operations when we arrive there. And part of my role on the mission is to make a geological map of the surface of 16 Psyche from the images from orbits A and B. And so what I'll be doing is I'll be practicing making that with data that we have in hand. You know, we can do it from the Peter Rubin artwork there. We actually had a class for our Psyche capstone students this last academic year, where part of their job was to make a geological map based on that artwork. But that's something that I'm going to be doing, and I'm building on techniques from geological maps I made on the previous mission like this, which was called Dawn, which actually visited Vesta and Ceres.
I think also, Alex, if you don't mind, we have two of those maps. So the two last slides are Ceres and Vesta. This is how I know Dave Williams. I know him to do this kind of work and make these kind of maps. Can you explain what we're seeing there? What are all those colors and stuff?
Yeah. If you go back to Vesta, yeah, okay. So each of these colors represents a particular type of geologic unit that was formed from some specific set of events. Now for asteroids, the major event tends to be impact. You can have impacts at the surface that can disrupt the surface. And you know, in the case of Vesta, there were two giant impacts at its south pole that caused seismic waves that disrupted different parts of the surface. So the blues down at the deeper blues at the South Pole are the basins of those two giant impacts. So is the light purple. The light blue are near just south of the equator are a set of equatorial ridges and troughs that were produced as a tectonic response to the formation of one of those basins, the younger one. And then those sort of diagonal light purple units there in the northern hemisphere are another set of ridges and troughs that formed as a tectonic response to the older impact at the South Pole. And then the yellow stuff represents more recent impact materials, and green is like mass movement, you know, where material moves down slope there. So you know,
and you can tell all this stuff not from being there, but you're orbiting, right? So is the orbits around Vesta, when you were learning all this information about Vesta, is it similar to the orbits that we'll have around Psyche? Is it
yes.
same instrument, same distance? So you'll be able to really sort of map out Psyche at this level with the instruments
exactly.
Okay.
You know, in the case of Vesta, our best resolution was 25 meters per pixel. In the case of the Psyche mission, our worst resolution is 35 meters per pixel, and our best resolution is going to be about 8 meters per pixel.
Oh, okay.
So we'll be able to make a global map that's better than what we had for Vesta. And then if there's interesting geology, we'll be able to actually make regional maps of interesting geologic features at much higher resolution. But that's the technique of map. You look at the images, and then you look at the contact relationships between the different units you see on the surface and determine the age relationships between them. And the same thing is true on the next map. This is the map for dwarf planet Ceres. And you can see there's a dark blue unit there around the remnant rim of an ancient impact basin. That's one of the oldest impacts on the surface of dwarf planet Ceres. And then the gray and light blue and peach colors there on the right side, that's another set of paired large impact craters, but they're younger than the one that's on the blue side. And then most of Ceres is the brown colors in there, which is a very heavily cratered plains. It's a very rich in hydrothermally altered rocks, probably the remains of an ancient ocean on this what was once an icy world, an ocean world.
Excellent. And really, by doing this, right, we find that Ceres and Vesta are two very, very different objects, right? There's very little similarity between the two of them, their makeup and the type of minerals on them.
That's exactly correct. And that was one of the goals of the Dawn mission, to visit the two most massive objects in the main asteroid belt and determine why, based on distant Earth-based telescopic observations, they appeared to be different. And the reason why they're different is partly due to composition, partly due to size, and partly due to the effect of impacts. Vesta is potato-shaped because of giant impacts at its south pole that excavated a lot of material to produce a particular family of meteorites that we have here on Earth. We call them HEDs. In the case of Ceres, it had much more water and water ice on it. The heat from the interior was able to alter the surface and produce a totally different type of mineralogy and appearance. And we expect something similar to Psyche, because Psyche being a metal-based asteroid, it could have a totally different type of geology on the surface than anything we've seen before. And that's really exciting.
That's exciting, right?
That. Yes.
Yeah, a totally third different, right? So just something we've never seen before, which is really why Lindy was able to sell this mission, right, to NASA and say, we've got to go investigate this because there's nothing else like it that we know of in the solar system yet, right? So it's
in Lindy's proposal, the proposal for the Psyche mission was actually the first try at getting a proposal for something like this funded, and she got it funded on the first attempt. That almost never happens because, people will come up with ideas for planetary missions and they'll submit proposals and they're reviewed and they always come back, oh, we'll make this change, make that change. And they go through 2 or 3 cycles before they're actually funded, but Psyche made it on the very first try.
Excellent. Okay, I'm going to ask Alex and Alicia, do we need to address any other audience questions just at the moment?
We do have a question from Jack, who wants to know who designed and builds the special conveyances, such as the truck to transport what we saw.
Oh, wow. That's interesting. That's a whole industry of itself, right? Not the spacecraft, but how you handle the spacecraft.
I would imagine Maxar Technologies, the company that built the Psyche spacecraft, has a long history of building Earth orbital satellites that use solar electric ion propulsion, and the body of the Psyche spacecraft is a typical body that they use for their Earth orbiting satellites. So they would have built many of these in the past over recent years to decades. So I'm sure they would have had the infrastructure to have a truck like that that's specially designed to move a satellite just like one that size, the size of the Psyche spacecraft. So I believe it would have either been theirs or would have belonged to the Jet Propulsion Lab. And of course, JPL has been building NASA's robotic spacecraft to go to destinations throughout the solar system, for decades. So they would also have that infrastructure available to transport a built spacecraft from one place in the country to another.
I could just imagine that thing rolling down I-5, right, in Central California.
He would have had escorts ahead and behind and to the sides to make sure it wouldn't have gotten into any accidents.
I would imagine
they probably did that in the middle of the night when there was the least amount of traffic on the freeways.
Alex, if you can call up the slide kind of in the middle of the deck that it just shows the configuration of the spacecraft itself. I think we'll kind of end there, and I'll ask Alicia if there's any. Are there any other questions we can address from the audience? That's the one. So go ahead.
I was just going to say, I think Clyde asks a very intriguing question. Might the craft fly closer to the surface at the end of the mission? And that might be something to touch upon, considering we've seen that with past missions.
Yes, the answer to that is assuming that the Psyche spacecraft operates properly during what we call its nominal mission, from when it first gets there to the time that its nominal mission to do orbits A, B, C, and D. If there are still resources on the spacecraft, such as ion fuel or cold gas thrust for maneuvering, if the reaction wheels work, if the solar panels are still generating plenty of energy, and if all of the instruments work, then typically what NASA will do at the end of what we call the nominal mission is the science team will put in a proposal for what they call an extended mission. And in that extended mission, we would propose, what is the best way to use the existing resources on the spacecraft? And typically what they would want us to do would be, okay, let's go lower. Let's drop closer. Let's get higher resolution images of the surface. Let's get higher resolution gamma ray and neutron data. Let's see if the magnetometers can detect any smaller sized magnetic anomalies on the surface. And from that, we would get an even better view of it. So I would fully expect if everything works well and we have the resources, that there would be an extended mission and we would go down closer. Alternatively, it wouldn't be unheard of that if the resources are such, and if we've actually answered all of the science questions that our instruments are designed to answer, we could propose to go somewhere else in the asteroid belt and do something else.
Like another target.
Another target, yeah. I think that's less likely than the possibility of doing an extended mission and staying at Psyche and trying to do something better, get better data.
Excellent. Hey, can I just have you point out for us? Actually, Alex, and maybe you'll have to do it. So just above the little sort of man's head there is a little word called cameras, and there's a little opening, right? So the cameras are in that little window. Is that right? And I say cameras because you're actually operating. It's two cameras, right?
That's right. We build two identical cameras for redundancy. The idea being that if one fails, you can use the backup. And so the cameras are in that little window, and one of them is mounted so it points straight out in the negative X direction. So what we would call looking nadir. If it was flying directly over the surface, it's going to be looking straight down. And then the second camera is at a slight angle of 3.7 degrees. And the reason why we did that is when we get down to orbit D, near the end of the nominal mission, we want to maximize our imaging coverage of the surface at highest resolution. So if we can use both cameras simultaneously, and we can photograph the surface, and there's going to be a bit of an overlap in the images. And that way we'll be able to cover the maximum amount of the surface in the minimum amount of time at the end of the mission if we choose to do so.
So you get the redundancy, but you also have a little extra special treat at the end if everything works right, and you get a little bit more coverage. So
exactly.
Sounds like a good way to do it. Okay, we're starting to run out of kind of our allotted time. What I wanted to do next is, why don't we play? We have a third video for you, and this should be a lot of fun. And this is us having fun with the idea that we're launching in a year, and we can't wait to get this thing out. Let's play that one.
Let's see. Give me a second. It's
okay. Sorry, we're asking Alex to handle all of the content, the images, and the videos today. So. I love it. It's excellent. All right. If I can, sorry to wrap this up. We're going to have updates as we go along. So this isn't the last the audience is going to hear about this mission for sure. As we get closer to the launch and as things come up over time, we'll ask our experts like Dave and Lindy and folks to come back. But I'm going to kind of turn it back over to Alex and Alicia if there might be another question or two from the audience. And then we also have some audience participation polls. So there's a couple polls about Psyche and what you might have just heard. We'd like to hear from you on that one too. So let's launch that.
Alex, you're muted.
Oh, thank you. Okay. So we'll launch the first poll. So have you heard of the asteroid Psyche? Yes or no? And then where is the asteroid Psyche located? You have your options there. So go ahead and vote in that. And then we'll take some questions. Or actually, David will take some questions. So
I think that the first question we're sort of, have you heard of the asteroid Psyche before the program tonight, right? Of course you have by now.
Yeah, that's a better way.
It's sort of like, yeah, is this something that's new to you, or have you heard about this project before? That's what we want to know.
And so we have a question from Patrick, who asked, what new instruments are being used on the 16th Psyche mission, that were not used on the Vesta mission? That's from Patrick Lochner. He says, hi, Dr. Dave.
Yes, Patrick. Well, the types, I mean, they were built by different institutions, but both Psyche and Dawn had multispectral imaging cameras. and both of them had gamma ray and neutron detectors. The difference with Dawn is it had a visible and infrared mapping spectrometer, which Psyche does not have. It has magnetometers. And because Psyche is a metallic object, we really want to be able to characterize, does Psyche have a magnetic field? Do parts of Psyche have a magnetic field? Are parts of it magnetized and parts of it are not? And this is all related to what we call our level 1 science objectives. These are the scientific questions that we must answer in order to justify the public tax dollars being spent to send a mission to this asteroid. And to answer those level 1 science objectives, there's sort of a decision tree that we use with the different instruments. So the imagers are going to see and gather certain types of data. The magnetometers are going to gather certain types of data. The gamma ray neutron detector is going to gather certain types of data, and how those data compare is going to be able to tell us the answer as to what 16 Psyche is. Is it a remnant planetary core? Is it a piece of unmelted metal? Did its core freeze from the inside out or the outside in? We'll be able to tell the answer to that based on the type of data we get from all of these instruments.
Excellent. All right. Is there another question?
Yeah, there's one. I know it was briefly touched on it about the extending the mission, but I guess once the mission fully ends, what happens to the spacecraft once the mission is over?
Well, typically what you do for these planetary missions, and it's a bit different depending on what kind of a body you go to. On Dawn, what we did with the spacecraft, we locked it in, but right before the fuel ran out, into a 50 to 100 year stable orbit around the dwarf planet Ceres. The idea being that solar wind might sterilize it, and if it eventually it will crash on the surface of Ceres. But we wanted to make sure it wouldn't be a danger to the surface in case there's any habitable material down there. When you go to some place that could be in a potential abode for life, like Mars or Jupiter's icy moon Europa with the liquid water ocean, you have very, very high planetary protection protocols. Now, in the case of 16 Psyche, I think it probably has the lowest level because it's a metallic body, and there's not any real evidence that it could have anything that would be amenable to any type of life as we know it. So I would imagine we'll probably do the same thing. We'll put it into a many decade stable orbit and before the cold gas fuel runs out. Eventually, though, it will probably impact onto the surface.
Sounds good. And the results of the polls was?
Yes. So
a lot of people have heard of it.
A lot of people heard of Psyche. I don't know if that was before you did the little addendum, but a lot of people have heard of it. But there are still some new people, and then the majority of people, 92%, got the correct answer. Psyche is between Mars and Jupiter. That is good. They're
audience. Yeah, you guys know that. We covered that quite a little bit. So, okay, super cool. Hey, the next thing I want to do is I just want to show you some stuff going on in the night sky. Just take me just a second to sort of set this up. I've got to do this little funky little share screen thing. Now I'm using, I think some of you that have been watching over time know that I use a little iPad with a product called Sky Safari Pro. And so let me just sort of get this launched. And you'll see, so here's when this comes up, there it is. So this is a view of the night sky looking west. And you can see that everything that is in green is below the horizon. Everything that is not in green is above the horizon. And this was about 50 minutes ago. So it was 30 minutes ago. It was at 7:10 tonight. So it's definitely dark enough to see the sky. I just wanted to point out the moon. And so before the show tonight, I walked out to my driveway and kind of looked towards the west, and I saw just this really just a sliver, like a little tiny edge of a fingernail of a new moon, just kind of gracing the night sky. I want to sort of show you the relationship here between the moon and Venus. You see Venus in the upper left hand side of this thing, a little bit higher and a little bit more towards the south, and the moon is there, and then again sort of the sun below the horizon. And then notice that there's other planets at play here. So Mars and Mercury are also here. They are dim enough and close enough to the sun that you're not going to see them. So I'm going to ask you not to look for Mercury and Mars. Just know they're there. But tomorrow night, I'm going to ask you to go out and actually for the next several nights, I'm going to ask you to kind of watch what happens to the moon. So here is tonight. Let me show you tomorrow night. Watch what happens here. And so the moon has now moved up so that it's right next to Venus. And then a very bright blue star called Spica is just below it. So that little triangle, that little triad, I think it's going to be very beautiful. So if it's cloudless like tonight, just right after about 7 o'clock, 7:15, get out there and take a look at this. And then notice also day to day the movement of the moon. Let me show you another thing. I'm going to back out to a much bigger view here. I'm going to show you the whole horizon from west to east. And see that arc going across the sky there, sort of almost like a little rainbow shape? Actually, here, let me do this. I'll just draw it for you, if I can. So you can see I'm going all the way from east, and I'm just going to kind of do this gigantic arc. I just passed through Neptune, Jupiter, Saturn, Pluto. Do all these sound like solar system objects? Absolutely. There is Venus, Mercury, Mars, and the Sun. The line I just described is what we call the line of the ecliptic. And it basically is the plane of the solar system. Remember, we're flat. And so all the planets are going to just travel at or near that particular plane. And here's what you get to see in the sky. So this is a great time to go out and just do some planet watching. Not only is Venus big and bright, easy to find, but now you have the moon as a little guidepost. I am going to tell you that the moon is going to move. So tomorrow night, it is right next to Venus. In several nights, it'll be next to Saturn and Jupiter. And I'm going to launch a little poll. I want everybody to guess how many days, how many nights is it going to take to see the moon would march all the way across the sky and do a conjunction with Jupiter instead of Venus. How long does it take to get from Venus to Jupiter? Let's see, how many days? I mean, look, they're all over the board. It's going to take this one, this one. All right. It looks like it's settling in pretty good here, okay? All right, are you guys ready to do a count? Okay, so the moon is right now right next to Venus. You can see that. Jupiter is our target in the arch across the sky. You guys want to count with me? So here we go. 1, 2, 3, 4, 5, 6, 7 nights. It'll be right next to Saturn. You'll be able to see that. And 8 nights, it'll be right next to Jupiter. So how did we do? We had 7 was the largest number, 8 was kind of like up there and in there. So this is really, I really like when we see the moon in this particular phase. It happens to us every 28 days. So this is not something really, really unusual, but just watching that little crescent grow, watching it move across the sky. And right now you have all these targets, the planets all the way along this arc that we can just sort of watch the moon move through this system. So I'm not asking you just to go out tomorrow night at 7:15, go out every night for the next 9 or 10 days and watch it go. 7 days from now, next Wednesday night, you'll have the moon and Saturn as your picture. 8 nights from now, you'll have the moon and Jupiter. Really quickly, we call these conjunctions. And so as the moon sort of and the planet sort of end up in the same ecliptic longitude, that means there's the same distance around the ecliptic. They don't have to be touching. One doesn't have to cross the other. They just have to be really close, and that's called a conjunction. So what we're seeing here is a series of planetary conjunctions over the next several nights. There's another term I'm going to introduce you to called occultation. And that would be if the moon actually moves fast and gets in the way of one of the planets. If it passes right in front of it and essentially occults the light from the planet for a period of time as it's moving by. We're not going to see that. The moon travels in its orbit. It changes sort of from above the ecliptic to below the ecliptic as it goes. And so we're going to see a series of conjunctions, no occultations in this particular case. But if you stay tuned every other Wednesday, I'll tell you when we might see an occultation. The moon is a bright object. That would be kind of cool to see. All right. That is kind of my sky watch for the night and something for you guys to go look for. So 7:15, start in the west, follow the moon across the sky for the next 8 days. Everybody's ready to do that, I think. Next, I'm going to kind of just go back to the team. I think we've got some things coming up. We wanted to talk about some resources about some of the things we talked about tonight. I'm going to have Dave hang on for a little bit because I think we need to hear about the Ron Greeley Center for Planetary Studies just a little bit more because that's his day job. He's the director of that particular program. And we also have some events events coming up. So I'm going to kind of turn it over to the next person in line. Well, I need to stop share, don't I? Sorry
That
about
would
that,
be
guys.
great.
Yeah.
Thank you so much, Rick. And
Thank
Dr.
you.
So I think you might still be sharing.
No, it's not. I can't push the button. I have to close the poll and then stop sharing. Okay, guys.
Alrighty. So for this week's current events, we have some exciting features to talk about. So super excited that NASA has officially announced that the James Webb Space Telescope will be launching in December of 2021. We're very, very hopeful for this launch date. So keep your fingers crossed and your thumbs held. October 7th at 7 p.m., we have our New Discoveries lecture series that's going to talk about what's coming after Hubble, right? And like I mentioned, that's James Webb Space Telescope, so you don't want to miss that. On October 22nd, we have our Earth and Space Exploration Virtual House. This is a free event, and we host it every single year, every semester, but this year, again, we're doing it virtually. So yes, it is virtual, just confirming on that. So make sure that you are checking that out as well. And then on November 13th, we have our virtual Earth and Space Exploration Day, or our EC Day, as we like to call it. And we invite you and your friends and family to join us for that event as well. And Kimberly Baptista will be sending out an email with all of those links in it, I believe.
We don't have to remember all those dates, right? So we're going to get this. But I think the big picture here is there's a lot of stuff going on, and we're also excited about, because our audience is going to be learning about James Webb Telescope as we go through this process. So this is the season this fall. Lots of stuff going on, lots of missions. We're going to get everybody updated on all of those.
Yes,
so thanks.
this is the time to get involved for sure. So
Right.
I think Alex might have some resources for us to talk about this week.
Yeah, we have more resources for more information about Psyche if you want to know more. We have a few websites. The first one is just the main Psyche webpage for ASU. That's psyche.asu.edu. All these links will be in chat as well. This is the Psyche page that we have. There's a lot of information. There's news, what the mission timeline is, some of our partners, and more information. You also have the NASA page for the Psyche mission at nasa.gov. This is another page for a lot of Psyche information and media. You have the JPL Psyche mission, another website about, information and when it's going to launch and, more about the mission. And then you have a website that is not directly related to Psyche, but still related in a sense. It's the Ronald Greeley Center for Planetary Studies and their website at ASU. David, I don't know if you want to talk about this more.
Yeah. So leave this up for a second. And what does the Ron Greeley Center do?
Yeah, we are the NASA Planetary Data Center at ASU. Back in the late 70s, early 80s, when Professor Ronald Greeley, he helped found our planetary geology program at ASU. He came here in 1977. He worked on NASA's Viking mission to Mars, the Voyager mission to the outer planets. He was involved with Mariner 10 to Mercury, Mariner 9 to Mars. So a lot of the early planetary missions. And, he died unexpectedly of a heart attack 10 years ago, 2011. And so our NASA Planetary Data Center at ASU was renamed in his honor. And so this facility, it has all of the actual photographic prints and film negatives of the mission, of the surfaces of the other planets, the photographs that were taken by NASA's early planetary missions from the 1960s through the 1990s. And we have a computer lab that accesses the NASA Planetary Data System, which has all of the digital planetary data that's now available. So it's basically a research lab for students to come in and to help them do research where they can take images for any given planet from various missions and put them all together in a what we call a GIS, a Geographic Information Systems mode, where all the latitudes and longitudes line up. So you can look at a given location on a planetary surface through multiple data sets to help you investigate various issues with planetary geology. Our lab also has a library of books and journals and mission documentation from a lot of the older missions from Lunar Orbiter and Apollo from the 1960s, all the way up to the most recent missions. So it's a resource at ASU.
And it's a resource for us. So when COVID is over, when you guys get to visit our place, not only do we have a projection ball in the lobby, we use some of the data that we get from Greeley Center to actually cover the ball, so those maps that we're seeing. And we also use them in the Marston Theater, so we can actually skin planets and asteroids and things with the maps and things that come from this particular resource. So it's really very, very cool. It's great to have on campus, and we're fortunate to have people like Dave and his team to help man that. So that's really super cool. All right.
And then
Can I
have
just?
one
I'm sorry. Go ahead. I'm sorry.
We have one last resource, just before we hand it back to you, Rick.
Psyche Inspired.
This is the Psyche Inspired. This is the video that was at the beginning of our presentation, but this is just a website that for the artists to get involved with STEM. This is a place to, showcase the interdisciplinary nature of science, and that's not just engineering, math, but it's also art and, design. And so here you can see a lot of artwork that have been done by artists, from everywhere about the Psyche mission. So it's a really neat webpage. It's a different view of science that we don't get to see very often, and that's another resource that I'd highly recommend checking out. Excellent. And those are our resources for Psyche. So make sure to check those out.
That's great. That was a really good collection of resources. All web-based this time, but that's really super cool. All right. Some upcoming visits to the virtual night skies. 2 weeks from now is going to be the Autumnal Equinox. It happens to fall on the day of our thing. So we'll be talking about equinoxes and why it's important and sort of what we notice in the sky and the way the light changes and the way the sunset's getting a little later and later and later. And hopefully we'll see a change in the weather once the equinox happens. So we're going to be talking about that, but we also have another guest, and it is Jessica Russet, and she's the deputy director of a program we call Interplanetary Initiative. This is very different. So you need to learn about this particular program. There's lots of ways for citizens to get involved. This is pretty amazing. And Jessica is a new deputy director for the program. We're going to meet her, and she's going to tell us about what that is. Interplanetary Initiative and Equinox. That's what we're going to do. 2 weeks after that, another guest professor, Everett Schock, will be with us. And he is going to be an investigator, just like Dave is on the Psyche mission. Everett Schock will be an investigator on an imager that is going to Europa, a moon of Jupiter. So we're going to learn about Europa and what that mission looks like, but we are also going to show you how to observe the moons around Jupiter. Jupiter is going to be well positioned in our sky for the next several months, and there's no excuse not to get out there with binoculars or a small telescope. We'll make it available to you. I'm going to show you how to look at those moons, how to determine which one is Europa, and we're going to learn about that moon and how you can actually observe the moons, the Galilean moons as we call them around Jupiter, and that will be 1 month from tonight. Or 4 Wednesdays from now. And so that's that. I'm going to leave you with an inspired comment. One of the things that I love about ASU and what I love about Lindy Elkins-Tanton, she is our former director and she's the principal investigator of Psyche, is she just likes to involve people. And she and her team conceived this idea called Psyche Inspired. We started our program with that video, those musician, young people who were sort of doing that particular composition inspired by Psyche. Alex just told you about the website where you can learn more about Psyche Inspired. So I'm going to draw us to a close, and I'm just about to say goodnight, but I'm going to ask you to hang on for another 3 minutes. We're going to play a really clever little video. It's like a little children's story to music, wonderful graphics, and I just think it is inspired, and it was done by a young lady that sort of just gets the Psyche idea. And as you watch this, you'll hear a little bit about what Dave talked about, what I talked to you about this asteroid and its unique properties and maybe its history. And so we're going to leave you with that. I will see you in a couple of weeks. I want to thank my team for helping me put this together. Another really great program tonight. So just as I sign off here, just watch for another 3.5 minutes and watch the video, and then we'll say goodnight. Thank you guys very much, and see you next time.
One day so long ago was a planet that began to grow more and more, day by day. Between Jupiter and Mars, she would lie out would make it far. She sang, someday I'm going to be a planet that's my destiny. I can't wait to see who I'll be. Following her orbit still, she would dance around as she grew, filled with joy through and through. Then one awful tragic day, some space debris flew in her way, struck her down to just a metal core. What was I going to be? What was my destiny? Now I won't ever see what could be. She would mope all day and night, wishing that she'd found a way to steer free of the debris. Then year 2026, a satellite from Earth appeared that traveled far to tell her this: you're special, unique as can be. Without you, we will never see what we are. We've come this far, so what will it be? That's when she had realized she was needed now for Earth to thrive. So she thought long and hard. Turning back to her new friend, said she'd gladly help and lend a hand, for she had found her purpose.